Welcome back, mathematicians. In this video, we are going to factor a quadratic expression, which happens to be a trinomial, where the leading coefficient is not equal to 1. So here we have 6x squared minus 7x minus 5. The challenge with this problem is that this leading coefficient is not equal to 1. If it were equal to 1, this would be a much simpler process. But because it's not, we have to go through a process called factor by grouping. Now, this is not the only way to proceed with this problem. You could, of course, do a guess and check model. I've heard of something called the slide and divide, but I like the factor by grouping because it is more of an algorithmic process. So the first thing you'll do when you are factoring by grouping is multiplying a and c together. So in this case, that would be 6 times negative 5, which results in a product of negative 30. Now our goal is to find factors of negative 30 where the sum of those factors is equal to negative 7. To do this, I like to create what is called a factor sum table. So I'm trying to find the factors of negative 30, and I want the sum of those factors to be negative 7. So let's go ahead and figure out what factors negative 30 has, and will result in a sum of negative 7. So the factors of negative 30 would be, how about negative 6 times 5? But negative 6 plus 5 gives us a sum of negative 1. So this one doesn't work. Okay, let's try again. We could choose, however, 6 times negative 5, but we know that's not going to work because that would result in a positive sum. And again, not the correct answer. So we know that the larger of the two factors must be negative for this to have a negative sum. So we'll focus on those types of factors. So next, how about we try 15 and 2? So we know 15 times 2, again, 15 will be our negative value. Well, this gives us a sum of negative 13. So again, not quite correct. And then finally, let's go ahead and try 10 and 3. So 10 times 3, and again, the negative value will be assigned to the larger of the two values, the two factors, which is 10. So now we see that the sum is negative 7, and this is exactly what we want because we want the sum to be the value of our b term. Now, our goal here is to create a quadratic expression that has 4 terms. And to do that, we're going to break up the negative 7x term into 2 different terms. So we'll have 6x squared, and then we have minus 10x plus 3x minus 5. So you'll see I chose the values that I'm going to break up negative 7x into are the values I have on my table, negative 10 and 3. We are now going to take the first 2 groupings of terms and we're going to factor. We're going to find the greatest common factor of those 2 terms. And the greatest common factor of 6x squared and negative 10x happens to be 2x. When we factor that out, we get a binomial of 3x minus 5. Our goal now is to repeat that process, but we're going to do it strategically. What do I mean by that? Well, I know that one of these factors, the binomial, has to be 3x minus 5 as well. So these two have to match. So then I ask myself, well, what can I factor from those 2 terms, meaning the 3x minus 5 from this part of the problem, to get that factor of 3x minus 5 in the next step? Well, I'm going to factor a positive 1. Now, it's important to recognize whether that's going to be a positive value or negative value because you do need to assign it a sign, positive 1 or plus 1, negative 1 or minus 1. Now, again, what we have are 2 groupings, and what we're going to do is factor the common factor of those 2 groupings. And we see the common factor of those 2 groupings is 3x minus 5. And so the other factor is what's left once we take out the 3x minus 5 from those 2 groupings, which will be 2x plus 1. And now we've successfully factored 6x squared minus 7x minus 5. And again, this is a great strategy because this can get a lot more complicated if the leading coefficient and or the constant become larger numbers with a lot more factors. Now, if you're curious if you did this correctly, what you would do is go ahead and apply the distributive property or FOIL to check to see if you can get back to the original quadratic expression. So let's just try that out. So we do f in the FOIL or multiply the first terms and we get 6x squared. We then do the outside in FOIL, so that would be positive 3x We then do the inside and FOIL, so what we get is negative 10x. And then finally, we would do the last in the FOIL, which is minus 5. Finally, we're going to combine those two middle terms, so we'd have 6x squared minus 7x minus 5. And so because this matches our original trinomial, this tells us we did do the problem, we did factor it successfully and correctly. All right, guys, good luck.